Double angle identities. Two special cases of the sum of angles identities arise often enough that we choose to state these identities separately. Identities. The double angle identities, sine of 2 alpha equals 2 sine of alpha multiplied by cosine of alpha. Cosine of 2 alpha equals cosine squared of alpha minus sine squared of alpha equals 1 minus 2 sine squared of alpha equals 2 cosine squared of alpha minus 1. These identities follow from the sum of angles identities. Proof of the sine double angle identity. Sine of 2 alpha equals sine of alpha plus alpha. Apply the sum of angles identity equals sine of alpha multiplied by cosine of alpha plus cosine of alpha multiplied by the sine of alpha. Simplify equals 2 sine of alpha multiplied by cosine of alpha, establishing the identity. For the cosine double angle identity, there are 3 forms of the identity stated because the basic form, cosine of 2 alpha equals cosine squared of alpha minus sine squared of alpha, can be rewritten using the Pythagorean identity. Rearranging the Pythagorean identity results in the equality cosine squared of alpha equals 1 minus sine squared of alpha, and by substituting this into the basic double angle identity, we obtain the second form of the double angle identity. Cosine of 2 alpha equals cosine squared of alpha minus sine squared of alpha. Substituting using the Pythagorean identity, cosine of 2 alpha equals 1 minus sine squared of alpha minus sine squared of alpha. Simplifying, cosine of 2 alpha equals 1 minus 2 sine squared of alpha. Example 1. If sine of theta equals 3/5 and theta is in the second quadrant, find exact values for sine of 2 theta and cosine of 2 theta. To evaluate cosine of 2 theta, since we know the value for sine of theta, we can use the version of the double angle that only involves sine. Cosine of 2 theta equals 1 minus 2 sine squared of theta equals 1 minus 2 multiplied by 3/5 squared equals 1 minus 18 divided by 25 equals 7/25. Since the double angle for sine involves both sine and cosine, we'll need to first find cosine of theta, which we can do using the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. 3/5 squared plus cosine squared of theta equals 1. Cosine squared of theta equals 1 minus 9/25. Cosine of theta equals plus or minus the square root of 16 divided by 25 equals plus or minus 4/5. Since theta is in the second quadrant, we know that cosine of theta less than 0, so cosine of theta equals negative 4/5. Now we can evaluate the sine double angle. Sine of 2 theta equals 2 sine of theta multiplied by cosine of theta equals 2 multiplied by 3/5 multiplied by negative 4/5 equals negative 24/25. Example 2. Simplify the expressions. A. 2 cosine squared of 12 degrees minus 1. B. 8 sine of 3x multiplied by cosine of 3x. A. Notice that the expression is in the same form as one version of the double angle identity for cosine. Cosine of 2 theta equals 2 cosine squared of theta minus 1. Using this, 2 cosine squared of 12 degrees minus 1 equals cosine of 2 multiplied by 12 degrees equals cosine of 24 degrees. B. This expression looks similar to the result of the double angle identity for sine. 8 sine of 3x multiplied by cosine of 3x. Factoring a 4 out of the original expression, 4 multiplied by 2 sine of 3x multiplied by cosine of 3x, applying the double angle identity, 4 sine of 6x. We can use the double angle identities to simplify expressions and prove identities. Example 2. Simplify cosine of 2t divided by cosine of t minus sine of t. With 3 choices for how to rewrite the double angle, we need to consider which will be the most useful. To simplify this expression, it would be great if the denominator will cancel with something in the numerator, which would require a factor of cosine of t minus sine of t in the numerator, which is most likely to occur if we rewrite the numerator with a mix of sine and cosine. Cosine of 2t divided by cosine of t minus sine of t equals cosine squared of t minus sine squared of t divided by cosine of t minus sine of t equals cosine of t minus sine of t multiplied by cosine of t plus sine of t divided by cosine of t minus sine of t equals cosine of t plus sine of t. Example 3. Prove secant of 2 alpha equals secant squared of alpha divided by 2 minus secant squared of alpha. Since the right side seems a bit more complicated than the left side, we begin there. Secant squared of alpha divided by 2 minus secant squared of alpha equals 1 divided by cosine squared of alpha divided by 2 minus 1 divided by cosine squared of alpha. At this point, we could rewrite the bottom with common denominators, subtract the terms, invert and multiply, then simplify. Alternatively, we can multiply both the top and bottom by cosine squared of alpha, the common denominator, equals 1 divided by cosine squared of alpha multiplied by cosine squared of alpha divided by 2 minus 1 divided by cosine squared of alpha multiplied by cosine squared of alpha. Simplify. Equals cosine squared of alpha divided by cosine squared of alpha divided by 2 cosine squared of alpha minus cosine squared of alpha divided by cosine squared of alpha. Rewrite the denominator as a double angle equals 1 divided by 2 cosine squared of alpha minus 1. Rewrite as a secant equals 1 divided by cosine of 2 alpha equals secant of 2 alpha, establishing the identity. As with other identities, we can also use the double angle identities for solving equations. Example 4. Solve cosine of 2t plus cosine of t for all solutions with 0 less than or equal to t less than 2 pi. In general, when solving trig equations, it makes things more complicated when we have a mix of sines and cosines and when we have a mix of functions with different periods. In this case, we can use a double angle identity to rewrite the cosine of 2t. When choosing which form of the double angle identity to use, we notice that we have a cosine on the right side of the equation. We try to limit our equation to one trig function, which we can do by choosing the version of the double angle formula for cosine that only involves cosine. Cosine of 2t equals cosine of t. Apply the double angle identity. 2 cosine squared of t minus 1 equals cosine of t. This is quadratic in cosine, so make one side 0. 2 cosine squared of t minus cosine of t minus 1 equals 0. Factor. 2 cosine of t plus 1 multiplied by cosine of t minus 1 equals 0. Break this apart to solve each separately. 2 cosine of t plus 1 equals 0, or cosine of t equals 1 plus 0. T equals 2 pi divided by 3, or t equals 4 pi divided by 3, or t equals 0. Looking at a graph of cosine of 2t and cosine of t shown together, we can verify that these three solutions on intervals 0 to 2 pi seem reasonable. Power reduction and half angle identities. Another use of the cosine double angle identities is to use them in reverse to rewrite a squared sine or cosine in terms of the double angle. Starting with one form of the cosine double angle identity, cosine of 2 alpha equals 2 cosine squared of alpha minus 1. Isolate the cosine squared term. Cosine of 2 alpha plus 1 equals 2 cosine squared of alpha, add 1. Cosine squared of alpha equals cosine of 2 alpha plus 1 divided by 2. Cosine squared of alpha equals cosine of 2 alpha plus 1 divided by 2. This is called a power reduction identity. The cosine double angle identities can also be used in reverse for evaluating angles that are half of a common angle. Building from our formula, cosine squared of alpha equals cosine of 2 alpha plus 1 divided by 2. If we let theta equal 2 alpha, then alpha equals theta divided by 2. This identity becomes cosine squared of theta divided by 2 equals cosine of theta plus 1 divided by 2. Taking the square root, we obtain cosine of theta divided by 2 equals plus or minus the square root of cosine of theta plus 1 divided by 2, where the sign is determined by the quadrant. This is called a half-angle identity. Identities. Half-angle identities. Cosine of theta divided by 2 equals plus or minus the square root of cosine of theta plus 1 divided by 2. Sine of theta divided by 2 equals plus or minus the square root of 1 minus cosine of theta divided by 2. Power reduction identities. Cosine squared of alpha equals cosine of 2 alpha plus 1 divided by 2. Sine squared of alpha equals 1 minus cosine of 2 alpha divided by 2.